Hello students. In this small session, I'll be explaining the turn-on switching characteristics of SCR, where because of some technical issues, I was not able to complete it during the live session. All right. So by the end of this session, you will be able to describe the turn-on switching characteristics of an SCR. Okay. So I just gave you some idea what switching characteristics means and what is the difference in turn-on switching characteristics, right? So switching characteristics means like we are looking at how the device, that is our SCR, behaves, say when it is switched from turn off condition to turn on condition, or turn on condition to turn off condition. So how does it behave? What are its characteristics? How it is responding to this change or switch in its the condition, okay, from off to on mode or on to off mode. So in this session we will be limiting ourselves to turn on switching characteristics. So you have gone through this, say, okay, to understand this, what do we do? Like, we have to look at the parameters, mainly the electrical components of the device, right? So we will be observing the voltage across it, and we will be looking at the current that we can measure from the device. So in order to understand the switching characteristics, we look at the anode to cathode voltage, and that is the current obtained from the device, that is anode current. All right. So we will be observing in the circuit, so where we have a pure resistance, so observing the parameters or recording the parameters, and if we are plotting it, okay, if we are plotting it, then the waveforms what we get would be this, which would be giving us the turn on switching characteristics, right? So anode to cathode voltage, we will take it as VAK, or you can take it as VA as well, okay, as shown in the figure. And the anode current, that is current flowing through the device, our SCR, we can call it as anode current, or as shown in the figure here, you can call it as thyristor current, that is IT, right? So when from our previous discussions, we know that whenever we are talking about turn on time, what is our turn on time? The turn on time, it is a summation of the three distinct time periods, that is delay time, rise time, and spread time, right? So which means that, as you can observe from the figure, whenever a device switches from off to on condition or on to off condition, it doesn't instantaneously change its behavior, right? So as we are already aware now, which means initially when the device is in off condition, the voltage across it will be maximum, and current flowing through it will be zero or minimum, isn't it? So when we turn on, say some for using any methods, the what we are discussing in the morning, using any of the triggering methods, if we turn on the device, immediately we don't see that there is a instantaneous increase in the current, okay, or instantaneous drop across it, isn't it? That we don't find that. So that means there is some delay, there is some time taken for the turn on process to happen and turn off to happen as well, which we'll be discussing later. So that is what we are trying to understand in turn on switching characteristics. So we have already gone through the details. So like when we give a control signal, or when I apply gate current at the gate terminal, okay, look at how the current is varying. So it's nothing but you have to understand here, you have a circuit with pure resistance and your SCR. So when the gate signal is given, or when you have applied enough voltage across gate and cathode, So there is gate current flowing through the gate terminal. So when you are going on measuring the anode current and the voltage, going on measuring the voltage across it, okay, as electronics engineer, you should be able to visualize the circuit diagram now. However, we don't have it, right? But you should be able to visualize and understand that. Say you have connected a voltmeter across the device and you have connected an ammeter in series with the device, and as you have given the gate signal, then you as it is varying, you are noting down the different readings of its voltage across it and the anode current flowing through it. Okay, so when you are plotting it, it would look something like this. Okay, that is what we have got it as a waveforms during the SCR turn on. So our delay time is nothing but, as we had have gone through earlier, delay time is nothing but it's a time duration where your anode current starts raising from minimum value to its 10% of its final value. All right, so when will this happen? After your gate current has reached 90% of its value, and after it reaches its final value, only then your anode current will start increasing. So now you have to visualize the internal structure of the SCR, the device, right? So when there is sufficient charges that is injected by the gate terminal, when there are sufficient charges, which will cause multiplication of charges inside the SCR device, which will in turn eventually will be causing the current to flow through the device. Okay, so then you say that there is increase in the current happening, correct? So this is our delay time. So parallelly, if you observe the voltage in the delay time period, the voltage will drop from its maximum value to its 90% of its value. So during this time, you can observe that. That is how you have to represent or interpret these waveforms. Okay. So based on the input, how are your outputs getting affected? That is how you have to explain. All right. So we'll come to this power loss later. Yeah. Then rise time, as you can see, the anode, now the gate current is it has reached its saturation value, or it is constant. Then once it is constant, that is the sufficient gate current is given at the gate terminal, then the anode current, it starts rising. Okay, now imagine the back-to-back connection of the two transistors. So the current what is coming from the gate terminal, it is connected to, say, base of transistor 2. Okay, so when it is triggering the transistor 2, then there is collector current at the transistor 2, which is connected to the base of transistor 1. So that is now injecting or flooding charges in transistor 1, which in turn will increase the collector current at transistor 1. Okay, so that in a loop, it is going on multiplying, and slowly the anode current of our SCR is increasing. I hope you are able to visualize the things. Okay, so the rise time is nothing but where our anode current increases from 10% of its value to 90% of its final value. Okay, so see, when you are explaining, it is not only like you are just saying device is turning on, the current is increasing and all, but at the background you should know its structure, its internal operation, eventually the basic electronics. Okay. Okay, during this rise time, observe the voltage across it. Now the voltage across it is slowly decreasing from its 90% value to 10% of its final value. Okay, as we know, when the typical characteristics, when the device is turned on, the voltage across it will be minimum and the current flowing through it will be maximum, isn't it? That is what the ideal characteristics of a switch is. All right, when the switch is closed, when the switch is conducting, when the switch is turned on, the current flowing through it will be maximum, the voltage through it will be minimum. Please note this, underline this sentence in your mind. It is very important to understand all these devices. Okay, this is basic. When the device is in off condition, the current flowing through it will be zero, voltage across it will be maximum. When the okay, if you are taking it as a switch is in open condition now. Whereas when switch is closed, current flowing through it will be maximum, voltage across it will be minimum. Okay, please understand this. All right. Then the last time is our spread time. Spread time is nothing but as you can observe where the voltage across the device it drops from 10% of its final value to the minimum voltage drop that will be there during the on state. Okay. In other words, zero point 0.1 VA to this final voltage across the on state of the device or the SCR. Okay, and here in terms of anode current, the anode current increases from its 90% value to its maximum final value. Okay, final maximum anode current. Okay, during this time it is a what we say it as the spread time. All right, and just to recall here, as I mentioned, the drop across the device typically across SCR will be 1 to 1.5 volts. This you have to remember. Some textbooks gives that it can vary from 1.1 to 1 to 2 volts. Okay, or 1.2 to 2 volts. Okay, the different textbook gives different values, but it is, you can say it as typically the voltage drop across the SCR during on state will be 1 to 1.5 according to the prescribed textbook what I am referring to now. All right. Now observe the power dissipation. What is power dissipation? We know that it's a product of V and I, right? It is a product of V and I, that is voltage and the current. All right. Now because of the variation in the voltage and the current across the device during this switching period, okay, so there will be power loss, or there can be power dissipation which will be creating say we call it as loss across the device. Okay, so if you observe the power loss here, so initially it is almost minimum. Okay, but during the rise time it is maximum. Why is that so? You observe here the current and the voltage during this rise time will be maximum, isn't it? Current is maximum during this time and voltage is maximum at this time. So when you take the product, obviously it will reach maximum somewhere in the middle of this rise time. Okay, so typically during when the load is RL type, so this rise time will be more. Okay, so the anode current, the rate of rise of anode current will be very slow in RL type of circuit. Okay, whereas in RC series circuit, this di by dt, that is rate of change of current of anode current, is very high, so the rise time will be less in RC circuit. However, there is one limitation there. Because of this power loss which is maximum in the rise time, okay, that which will create hot spots in the circuits which can damage the device or our SCR. So to limit this rate of rise of the current, generally the inductors will be used in the circuits so that it will limit di by dt, that is rate of change of current. Okay, so which means that we don't want the current to like instantaneously rise up, shoot up. Okay, so to limit that, inductors will be used because of this power loss or the hot spot that gets created in the device. Okay, so all these precautions should be taken during different applications where SCRs will be used in switching power electronic circuits. I hope this is clear now. So we'll continue in our next session.